You can do what you want.
Okay, so yeah, so when they give you a probability distribution and they want you to get the mean and standard deviation, you can just put it in your list. So you go to Stat and then Edit and then clear that stuff.
Yeah, that's all.
So your X's, you put in list 1, oops, 2, 3, 4, and then your probabilities. Okay, and then to get the mean and standard deviation, you'll go to Stat, Calculate, 1 var stats for L1 and L2. And you want X bar, that will be your mean, so 1.45, 1.45, and then you want this little sigma,
Right.
So 1.12.
Gotcha.
Yeah, and that would be that.
Awesome.
And then it asks you if it's unusual to find 4 voters. So one way to determine whether something is unusual when they give you the probability is to compare that probability to 0.05.
Oh, okay. So you're looking at 4. So you look at the line of 4 and see
Yeah.
what number that's on.
Exactly. So
Gotcha.
because they give you the probability, you're going to compare that probability to 0.05. And because this number is smaller than 0.05, you know that it's an unusual event. But if they would have asked, you know, is it unusual to get 1 voter? That number is larger than 0.05, so that one would not be considered unusual. So
Okay.
that's that one.
Awesome.
That's section 5.2.
Okay.
Okay, that's that. Number 2. This one's really straightforward. I mean, he just gave you all the possible outcomes and their associated probabilities, and he's just gonna pick one of them. Like he's gonna say, find the probability of getting exactly 4, or 9 or more,
Right.
or less than 10.
And we did go over something like this. I don't know if it was this one, but we did do some where you add, if it's 9 or more, you start from 9 and then go all the way up to 14 and add all those sums, and that's the probability.
Exactly. And so saying 9 or more is different from saying more than 9, right?
Okay, I'm glad you said that because I was like, it's the same thing.
Because 9 or more means you want to include the 9.
Right.
More than 9 means you don't want to include the 9.
Right,
So you would
right.
start at 10 and above.
Gotcha.
So just depending on which of those situations he gives you, you would just look at, you know, the probabilities. So it's just a matter of adding.
Gotcha.
You know, so that's straightforward. That's also 5.2. So now 5.3, for this number, that's where they start talking about binomials. And so you need to know,
They're not. I'm
we
just
kind of
saying.
went over this last time too, like the characteristics of a binomial.
Right.
There's
The 4 of them, right?
They have to be independent trials. They have to tell you how many times they're going to do, you know, whatever event they're going to do. There can only be 2 outcomes, and the probability of a success has to remain the same each time. In other words, it has to be with replacement, and they have to be independent.
Gotcha.
So he'll give you like some situation, and then you just have to see if it meets those 4 requirements.
Gotcha.
So I think, did you want to go over this one? Or are you kind of good with that?
I think we did go over something like that before, so I think we can move on.
Okay. So yeah, so that one's that.
Okay.
And then I guess you wrote down the page number.
Right. I think those are the ones that were the requirements.
Yeah. Yeah, that sounds right. Okay, so then the last section from chapter 5 would be calculating the mean and standard deviation for a binomial.
Okay.
So like number 4, this is from section 5.4. So for the mean, there's a formula. It's n times p. And then for the standard deviation, there's also a formula, which is the square root of n times p times q.
Okay.
Right?
Because it just sounds funny that it's like, oh, n times p times q.
So the question...
The alphabet's doing stuff together. You know, they like to hang out, party.
Yeah, of course. So the question will always give you n, and they'll give you p. So you just use those numbers. Like, here's the n, here's the p. If you multiply the 18 and the 0.4, you'll get your mean. And then to get q, you know that it's 1 minus p. So if you know p is 0.4, Stop laughing.
No. Okay.
Then you know Q is 0.6.